Hello friends, today I'm going to talk about Leetcode 678, valid parenthesis string. Give a string that contains only three types of characters, left bracket, right bracket, and star, and you have to write a function to check whether the string is valid. So here we have some rules. That is, the left parenthesis must have a right parenthesis, and the right parenthesis must have a left parenthesis, and also the left parenthesis must go before the right parenthesis, and also the star could be treated as the left parenthesis, right parenthesis, or empty string. We have these examples, and this is the valid, and this is the second example is also valid. The third example is also valid, and the star could be treated as the left parenthesis. So let's analyze this question. So here that we given a string, we judge whether it valid, and we have the star. And here star could be treated as the left, right parenthesis, and star. So one idea that is we can use brute force to we treat the star as one of them and traverse all the possible ways. So we can use write a recursive function to find all the possible ways. So this should be easy to come up with when we write recursive function. That is, for example, we have this DFS hyper function. That is a string and the current index, and also the count of the difference of the left bracket and parenthesis and right parenthesis. And when we index values, the string index values is star here, and we continue to traverse these three values here, whether they are all whether one of them could be valid. So one option is that we treat it as a left parenthesis, so the count plus 1, and the second option is that we treat it as right parenthesis, so the count is -1, and the third option is that we treat it as empty. So basically, this is the core of recursive function, and I think the time complexity is O3 power n is the number of the string. Because here we have the constraint that is n is about 100, so it should be the 3 power 100. That is very huge. I think that will definitely cause the time limit exceeded. So okay, the second solution that is we can optimize that with stack. This is not very obvious to come up with. So let's consider that if we have the star here and the star, and this one case is only one star. The second case is star left bracket, star right bracket, and also this case, this is a basic unit of all the possible cases with star. we have found that only for this second case, if we have the star and the left bracket, this is not valid anyway. We can because even if the star is empty or is left bracket, we cannot consider it as is valid. So this indicates that this star's index is must be after then the left bracket's index. That is, the star index cannot be before the left bracket index. If it is before, we will find it's not valid. So we can use two stacks, left bracket stack, and also the star stack. And we will when we traverse the string, we put the star's index in the star stack, and also the left bracket index into the left bracket stack. So we will pop it out and to check whether there is any case of this happens. If any case of this happens, we will return the false. Let me give an example here. For this example, we have the string star, and this is not a valid string. This should be returned false. For the first three, is valid, so we can use a simpler test case. And this is so this is not valid anymore. And if we have traverse this index from 0 and 1 and 2, we have the left star here and star stack here, and when it's when we traverse the first left bracket, where we have index 0 into the stack, and star is still empty. And then when we traverse the second, we put it into the inside, and also put the star stack is also empty. When we traverse the second, the left is still empty, and right is 2. So after we get it, we will pop the left and the stars stack at the same time. So we check the 1 is 1 is smaller than is, so it works. And then we found there's still left empty, so we will return false. This case should be that there's still left. This is still left. Left bracket is still left. There's no one characters that could be matched with the left bracket. So with this idea, we could find out whether the string is valid. So let's basically write the code here. Let's define a stack is left bracket. and also the stack on of the star, and get the string length, and we traverse this string. And if the current string is the left, we put in the stack. If the current is star, we put in the star stack. And if it's right bracket, if it's right bracket, we have to cancel it out. So we have to check whether the left bracket is empty. If it's not empty, we have to pop -1. This is not the case. This case, or this case. This should be doesn't matter, because as long as there's a left and right, they could cancel out. So we will pop it. Or the star stack is not empty. This is for the case that this case the stack could be the left bracket. So we could also cancel one pair, that is stack pop. Otherwise, that is what happen if we couldn't have, if we have the if they are all both empty, we have this or this right. So this means that is not valid, return false. After that, we will traverse the stack and check both stacks should be not empty, and then we check. We have to make sure the star should be before the left. Should after the left. If it's after left, that is valid. This one is valid. This one is not valid. So we traverse of them one by one. If the index is left is bigger than the index of the star, we return false. Otherwise, we have to pop both from the two stacks. And after that, like the other cases, is that if there's only star left in the stack, there's no problem. If we have the bracket left in the stack, that we will return false. So if they still have bracket left, we will return false. Otherwise, we return true. So basically, this is the idea. Okay, let me try other test case. Yeah, we made it.